What we need to understand now is how to convert from moles to mass. So like I mentioned earlier in the other video, 1 mole is not only equal to Avogadro's number, but it's also equal to molar mass, which a lot of times we call atomic mass, which is just looking at your periodic table and adding up the masses from the periodic table. Okay, so again, nothing different than what we've previously done. So if we look here, molar mass is going to be the mass of 1 mole of an atom or molecule. Again, here's all the different terms that are interchangeable with that. So for example, if we're trying to find the molar mass of water, we're going to look at our periodic table. Hydrogen has a mass of 1.0. Always use 1 decimal place. Okay, so we're going to round. Oxygen has the mass of 15.99, so we're going to round that up to 16.0. And there's 2 hydrogens, so we have to take this times 2. So we're going to have 2 plus 16, and our molar mass for water is going to be 18 grams. Or we can say AMUs here too, but most of the time when we're dealing with mass, we use the label grams. So here's an example. If we're looking at carbon, again, average atomic mass is how many grams for 1 mole. If we look at the periodic table, carbon weighs 12.01. For oxygen at 16.0, like I just said, we're only going to use 1 decimal place, even though these have 2, and hydrogen is 1.0. So again, you're just going to look at the periodic table. Sometimes you'll see it as a label as grams per mole, because we're saying that it's that many grams for 1 mole. So again, don't let that throw you off either. It's all the same. So the molar mass again is going to be equal to the sum of the molar masses of all your atoms in your substance. Okay. Just the definition one more time. So here are the steps that we're going to go through. You're going to count the number of each type of atom. You're going to find the mass of each atom on the periodic table. And then we just multiply how many atoms we have by that mass, and then we sum it all up. So here we're going to look for calcium bromide, so CaBr2. So if we look here, we go to the periodic table. There's 1 calcium, there's 2 bromines. We look up the mass of calcium. We would round that to 40.1 with 1 decimal place. And then our bromine is 79.9, so we're going to round that to 80.0. And we'd add those up, or take that times 2, excuse me, and then we're going to add those up. Okay, so we got our 2 masses here. We would have, rounding it, we would have 40.1. And here we would have 160.0. Okay, add those up and we get 200.1 grams per mole. Okay, so you just add those up to get your final answer. And that's how we deal with molar mass. Now, if there's a parentheses there, like for example here, SR, and then we have an NO3, 2, that means we have 2 of everything inside this parentheses. So as we work through this problem, okay, I'm not going to round everything, but make sure you round everything to 1 decimal place. We would have 2 nitrogens because the nitrogen's inside of there, and we would actually have 6 oxygen because you have 3 inside the parentheses and you have to multiply that times 2. And then again, you would add everything up. So we would have 211.6 here when you add all those up. So that's how we deal with molecular mass. Here, for our aluminum hydroxide, our O and H are inside the parentheses, so here we're going to have 3 oxygen and 3 hydrogen. So we have to take those masses times 3 before we add those up.